Hello students, in this class we will learn how we can find the image of a point with respect to a straight line. Okay, so let us study the question. Find the image of the point having position vector I cap plus 6j cap plus 3k cap with respect to the line r vector equals to j cap plus 2k cap plus lambda times of I cap plus 2j cap plus 3k cap. Okay, that means if we represent this problem by a diagram, then say P be the point whose position vector is I cap plus 6j cap plus 3k cap, and this is the line which is r vector equals to j cap plus 2k cap plus lambda times of I cap plus 2j cap plus 3k cap. Now, if we drop a perpendicular from this point P on this line and produced it up to the point P dash in such a way PQ equals to P dash Q, then P dash will be the image of this point P. Okay, that means if PQ is perpendicular to this line and when PQ is produced to P dash in such a way PQ equals to P dash Q, then we can say P dash will be the image of this point P. Okay. Now, if PQ perpendicular to the given line and PQ equals to QP dash, where PQ is produced to P dash, then we can say that P dash is the image of the point P with respect to the given line. Okay. The position vector of the point P is I cap plus 6j cap plus 3k cap. So, its Cartesian coordinates equals to 1, 6, 3. Again, the vector equation of the line is r vector equals to j cap plus 2k cap plus lambda times of I cap plus 2j cap plus 3k cap. Therefore, the Cartesian equations of the line becomes x by 1 equals to y minus 1 by 2 equals to z minus 2 by 3, as r vector equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times of a1 I cap plus b1 j cap plus c1 k cap implies that the Cartesian equations of the line are x minus x1 by a1 equals to y minus y1 by b1 equals to z minus z1 by c1. Okay. By following this way, we can write the Cartesian equations of this vector equation of the line are x by 1 equals to y minus 1 by 2 equals to z minus 2 by 3. Okay. Let the coordinates of the point Q be lambda, sorry, mu, comma 2 mu plus 1, comma 3 mu plus 2. Since if we let x minus x by 1 equals to y minus 1 by 2 equals to z minus 2 by 3 equals to mu, then x equals to mu, y equals to 2 mu plus 1 and z equals to 3 mu plus 2. By following this way, we can take the coordinates of this point Q on this line as mu, 2 mu plus 1, 3 mu plus 2. Okay. So, the coordinates of the point Q becomes mu, 2 mu plus 1, 3 mu plus 2. Okay. And the Cartesian equations of the straight line are x by 1 equals to y minus 2, sorry, y minus 1 by 2 equals to z minus 2 by 3. So, direction ratios of this line are proportional with 1, 2, 3. Say they are as A1, B1, C1. Now the direction ratios of the line PQ are x2 minus x1, y2 minus y1, z2 minus z1. This point is x1, y1, z1, and this point is represented by x2, y2, z2. Okay. This will give mu minus 1, 2 mu plus 1 minus 6, 3 mu plus 2 minus 3 equals to mu minus 1, 2 mu minus 5, 3 mu minus 1. Say they are A2, B2, C2. Since PQ perpendicular to the given line, say this line is capital L. Capital L. Therefore, A1 A2 plus B1 B2 plus C1 C2 equals to 0, as when two straight lines becomes perpendicular, then sum of the product of their corresponding direction ratios is equals to 0. So by this way we can write A1 A2 plus B1 B2 plus C1 C2 equals to 0 when PQ perpendicular to the given line L. This imply 1 into mu minus 1 plus 2 into 2 mu minus 5 plus 3 into 3 mu minus 1 equals to 0. This implies mu minus 1 plus 4 mu minus 10 plus 9 mu minus 3 equals to 0. This implies 14 mu minus 14 equals to 0. This implies mu equals to 14 by 14 equals to 1. So, the coordinates of the point Q becomes 1, 2 plus 1, 3 plus 2, which is equals to 1, 3, 5. So by this way we can find the coordinates of this point Q, okay, where Q is the point normal, Q is the point of incidence, where Q is the point of incidence, okay. So the coordinate of this point Q becomes 1, 3, 5, okay. Let the coordinates of the point P dash be alpha, beta, gamma. Since PQ equals to P dash Q, therefore Q will be the midpoint of the line segment P dash. So 1 plus alpha by 2 comma 6 plus beta by 2 comma 3 plus gamma by 2 equals to 1, 3, 5 by following the midpoint formula. That means if this point P is x1, y1, z1 and P dash is x2, y2, z2, then the coordinates of the midpoint Q will be x1 plus x2 by 2, comma y1 plus y2 by 2, comma z1 plus z2 by 2. Okay. So by following this way, we can write the coordinates of this point Q by this way: 1 plus alpha by 2, comma 6 plus beta by 2, comma 3 plus lambda by 3 plus gamma by 2, which is equals to 135, because already we know the coordinates of this point Q. Okay. This imply 1 plus alpha by 2 equals to 1. 6 plus beta by 2 equals to 3. 3 plus gamma by 2 equals to 5. This imply 1 plus alpha equals to 2. 6 plus beta equals to 6. 3 plus gamma equals to 10. This imply alpha equals to 1, beta equals to 0, gamma equals to 7. Thus, the image of the point P 163 with respect to the given line x by 1 equals to y minus 1 by 2 equals to z minus 2 by 3 is alpha comma beta comma gamma equals to 1, 0, 7. Okay. This is the first part of this question. That means, first of all, we have to find the image of this point 163 or I cap plus 6j cap plus 3k cap with respect to this line. Okay. So this is the way by which we can find the image. Okay. Now we have to find the equation of the line which joins this point P and its image P dash. Okay. The Cartesian equations of a line which passes through the point points x1, y1, z1 and x2, y2, z2 are x minus x1 by x2 minus x1 equals to y minus y1 by y2 minus y1 equals to z minus z1 by z2 minus z1. So, the Cartesian equations of the line joining the points P163 and P dash 107 are x minus 1 by 1 minus 1 equals to y minus 6 by 0 minus 6 equals to z minus 3 by 7 minus 3 imply x minus 1 by 0 equals to y minus 6 by minus 6 equals to z minus 3 by 4 imply x minus 1 by 0 equals to y minus 6 by minus 3 equals to z minus 3 by 2. Since 2 becomes the common factor from minus 6 for minus 6 and 4, that is why we can take that common factor, and after taking that common factor 2, or you can say by multiplying all of this by 2, we get x minus 1 by 0 equals to y minus 6 by minus 3 equals to z minus 3 by 2. Which is the required equations of the straight line. This is the way by which we can find the image of a point and the Cartesian equations of a line which joins the given point and its image. Okay.